So we got this situation here where we got this equation, right, where we've talked about it a little bit, but not enough to totally answer these questions without doing some critical thinking, right? So it says, what type of function is this, and how do you know? Well, if you forgot about the lesson a few days ago where we briefly mentioned this form, and I don't even know I think we gave you one example, right? If you forgot about that, you could think it through, right? You could think to yourself, well, it's got these parentheses, right? And usually when we get these parentheses, we multiply them, right? We multiply them, we FOIL, we box, or something like that. So I think to myself, well, what would happen if I did do that? Right? What would happen? What would I get if I FOILed or boxed this? Like, just don't even have to do the whole thing, but what would be the first thing I would do? X times x. Like, that's the first part of FOIL. And what does x times x give you? X squared, which means it has to be a quadratic, right? So that would be how you would kind of critically think your way through this one, even if you haven't seen it before. It has to be quadratic because x times x is x squared, and we know x squareds are quadratics, right? And then if we know that, it says, well, what will the graph look like? A U shape, which we call a parabola. So, okay, parabola. And yes, that is a U shape. Okay? All right. Now, the next thing it says is graph the function. And like we often do here, we're going to do it with a table, and then we're going to talk about how to do it without a table in this class. So, okay, with a table, well, all we do is plug in. You plug in your x to find your y. Remember, anytime you have a function, it's actually, you could actually rewrite it as y equals. So I'm going to do that over here on the side. This function is actually y equals 2 times x plus 4 times x plus 2, right? We use our x to find our y, right? We just plug in our x to find our y. So we'll just have to do that for each of these, right? So I'll do it for a couple, and then I'll fill in the table. So for the first one, y equals 2, and then instead of x, I have 0 plus 4, and then instead of x, I have 0 plus 2, right? Just wherever I see x, I put my x, right? Does that make sense, right? Okay, so now I just do the math, okay? We got order of operations, parentheses first, and then we'll multiply. So this becomes y equals 2. 0 plus 4 is 4. 0 plus 2 is 2. 2 times 4 times 2. 2 times 4 times 2 is 2 times 4 is 8, times 2 is 16. So 16 is your y when x is 0. Okay? Do another one. So you might then say, okay, let me go again. Y equals 2 times negative 1 plus 4 and negative 1 plus 2. Okay? Well, parentheses first, right? So y equals 2 times negative 1 plus 4 is 3. Negative 1 plus 2 is 1. So, no, negative 1, positive 4, right? Yeah. So 2 times 3 times 1, 6. Okay? So you would just do that for each one. Find these y values, and then you have points, right? Because every one of these is a point. So if you did that, if you continued that process, you would get 0, negative 2, and then 0 again. Okay? And just plug in negative 4, do the math, right? Okay. So remember, every one of these is a point, right? This is 0, 16. This is negative 1, 6. This is negative 2, 0, right? And so on, right? These are all points. That's why we do these, right? So we can add them to the graph. So we're going to do that. Now, 0, 16. Well, that's off the graph, right? It's way up here. So, oh well, right? When you're plotting points from a table, you're just trying to get enough points to get the shape. And why did we answer those questions first? Why did we make predictions before we even did the table? Because we want to know what to expect, so we know if we did it right. What should we expect to see? A U, a parabola, right? If I don't see that, I'm going to go back and check my work, because that's what I know it should be, right? So that's why we make predictions in math before we do any of the actual math, to check our work, to sense check. All right? Our next point was -1, 6. We had -2, 0. -3, -2, -4, 0. Okay. Hopefully, you start to see the U, right? Like this is becoming a U. Now, that's all the points we had, but that's not all the points that exist. What point do you think we could add here just based on what we know about parabolas? Yeah, -5, 6. How did everybody know that?
Because parabolas are symmetrical.
Parabolas are symmetrical around the vertex, which is on the axis of symmetry, right? It's all coming together, right? So we know our axis of symmetry is right here, because that's where the vertex clearly is, because it went down and it was coming back up. So that means points flip over that, and that means we can add that point pretty easily, and we get our completed parabola, right? Okay? Now, what do we notice about our equation here and our graph? What do they have in common or similar? Yeah.
The x-intercepts.
The x-intercepts are -4 and -2. And we have +4 and +2. I bet you that's not a coincidence. We're going to talk about that some more. What is this form called?
Intercept form.
Intercept form, right? It's in the name. Like you're going to be able to find x-intercepts from this form. That's the whole point of this form. Okay, so let's finish this warm-up. It said, hey, write 2 more equations from this graph. Well, what other types of forms do we know? Question.
I have a question.
Yeah.
How is -4 0?
We're going to get there. That's
Because when you have to put the -4, it's going to be like copying -4 too.
Well, you want me to plug in -4? I'll prove it. Ready? Y equals 2 times -4 plus 4 and -4 plus 2.
Yeah.
Right?
0 and -2. 2 times -2 is -4.
This would be 2 times 0 times 2. Or -2, sorry. 2 times 0 is 0. 0 times -2 is 0. And that's why it's 0.
Oh, I removed the 0. I just didn't count the 0. Okay.
All right. So, we're going to write an equation. And we know vertex. And what other form do we know? Standard, right? So our challenge is to write in those 2 forms, okay? You have a graph now, you have a vertex, right? You also know how to go from 2 binomials to a trinomial. So now if you haven't gone that far, I want you to work on that now, okay? So, vertex, right? We need to just grab our vertex. We know our A. We plug that stuff in, right? Vertex form is y equals A times x minus h squared plus k. So we need these 3 pieces. A, h, k. Okay? Okay. All right. A equals, H equals, K equals, right? We did this on the homework, right? We just need to pull those pieces, right? Luckily, we have a graph, so we know our A from our equation and our graph, right? Our A is given here. I also see over 1 up 2, so I know my stretch is 2, my A is 2.
Wouldn't it be -2?
-2 would flip it down, right? The negative flips it. So it's not flipped. So our A is 2. And then our vertex is what? -3, -2, which is my HK, right? So I just put those down, as my H and K, kind of flying here around, sorry. -3, -2. Now I have all my pieces, I just plug them into the formula, right? So we have y equals 2 times x, well, it's minus h, right? Minus 3 is plus 3. Does that make sense? I don't want to skip that step if people don't understand that. Minus is plus. And then I have plus k. Well, plus minus 2 is minus 2, right? So we have vertex form. Now for standard form, we haven't done this yet, so there's a little bit of a lesson within the warm-up here. So make sure you're paying attention to this. This is converting. So we're going to convert from intercept to standard here. Okay? So what was our equation? Our equation was y equals 2 times x plus 4 and x plus 2, right? I think. Confirm? Yeah? Okay. So, well, how do you think we could go from 2 parentheses to 3 terms? Foil or box, right? That's why we practice it so much. So, I need to figure out what x plus 4 times x minus 2 is. And I'm not worried about that 2 yet. I deal with that at the end. Question?
Why do you sometimes do like the 2 with the first one and then leave the second?
I usually don't. I usually figure out what this is, then I multiply by 2.
Because, I don't know, like when you have 2 and there's something outside, you do the outside with the first one and you leave the second one.
So here's maybe what you're saying. Like if I have like numbers and I have like 2 times 4 times 3, like that, I will go left to right. I'll go, okay, 2 times 4 is 8 times 3, that's 24, right?
I don't know.
I'm just saying multiplication, right? Product. I just go along the way. But you don't have to. I could say, what's 4 times 3? That's 12. 2 times 12 is 24. Like I can multiply in whatever order I want. Okay? So because of that, I'm going to multiply the hard stuff first and then worry about just multiplying it all by 2. Yeah?
Why does it say convert from intercept?
Because this is intercept form,
Oh,
and we're converting it to standard.
okay.
Yeah.
That makes sense.
Okay. All right, so I'm going to figure out x plus 4 times x plus 2. Let's FOIL this since we've already boxed today. First, outer, inner, last gives me x squared plus 2x plus 4x plus 8, right?
Can you not box it?
Of course you can. We already did a box example, so I'm doing a FOIL example. Yep. So 2x plus 4x, that's 6x. So this is x squared plus 6x plus 8. Okay, so what does that mean? Why do we do that? Well, now we know that this is the same as this. They are equal to each other, right? One is the other. If things are equal to each other, we can flip them and plug them in each other's place, right? That's true in math, right? So that means now I can say, instead of this, I'm going to put this there, right? And I say, okay, y equals 2, and then not that, I'm going to do that. X squared plus 6x plus 8, right? Now it's going to be, this is why I waited on the 2, because now it's really easy to just distribute that 2 through, okay? So this 2 goes to everything, right? And I get y equals 2x squared plus 12x plus 16. And that is in standard form, right? So now I've seen this equation in 3 different forms, and it all has the same graph, right? So we're kind of coming full circle here. Okay, before we move on, Can anybody tell me how I could sense check and confirm that that is the right standard form for this graph? Yeah, what do you think?
Find it from vertex form.
Well, with no more work, just I got this answer as my standard form, and I'm going to look at the rest of the work I've done and say, hey, I think I did it. I think I did it right.
Y-intercept.
The y-intercept, right? Remember the c value is your y-intercept. Your y-intercept happens when? When x is 0. Didn't we calculate when x is 0? Yeah, right here. And what did we get? 16. And what do we see? 16. So I know that I got the right standard form here. I can be pretty confident. Okay? So there you go. Now we can do all three forms. Okay? All right. So intercept form. Let's continue with intercept form here. So just as a reminder, or like we'll just cover it again real quick. Intercept form, right? Let's block this off. Boom, boom, boom. Intercept form is y equals a times x minus p times x minus q, right? That's what intercept form is. It's got three different pieces. It's got the a that we are always used to seeing. It's got a p, and it's got a q, okay? This a is our stretch and reflection, right? Always. What's that? That is a P. That's a P. That's a pretty good P. Come on. I know my handwriting's terrible, but that's not my worst work. So stretch, these words might be. Stretch and reflection. Okay, so that's our P and our Q. Let's lock back in here. All right, so our P and our Q are our, do any of you remember what we said these are? There are x-intercepts. Okay? And what's really important to realize here is that if it's x minus p and x minus q, my x-intercepts are p0 and q0. Right?
Does it matter if it's in order, like, or 0?
It doesn't matter which one you call p and which one you call q.
But, like, I'm saying, does it also matter if you put 0 dash q, comma q, or does it not matter?
0 dash q.
Comma.
Yes, it does matter because it's your x-intercept.
Oh, all right.
That would be a y-intercept, what you're talking about. Yeah. All right, so what do I mean by that? Well, let's think about our example before. It was x plus 4, right? Guys, bring it together. It was x plus 4 and x plus 2, and our intercepts were where? Where were our intercepts?
-3, -2.
Can you please? So it was -4 and -2, and we had +4 and +2. So what do you think we're going to have to do to get our x-intercepts every time?
Flip it?
Flip the sign. Flip the sign. All right? So, important takeaway. You must flip the sign. Okay? So, this is always good to be seen through an example. So, let's go with an example real quick. All right, so let's say you had y equals -3 times x plus, or we'll go x minus 2, x plus 4, right? If you were asked to pull the pieces out of this, well, you would say, okay, my a, my p, and my q are what? A is -3, p is +2, and q is -4. You flip those signs, and this is the biggest mistake people make is they don't flip them and they get the x-intercepts in the wrong spot, right? Because this graph would look like this. There would be a point at 2, right? And then there would be an x-intercept at -4. And then you look at the equation, it's positive 4 and negative 2. Okay, so your graph would look something like that, right? And we're going to talk about how to, oh, actually, no, it's a negative, so it would be flipped down. And we're going to talk about how to find the vertex on the next page. But just in terms of your sketch right now, negative 4 and 2, and your vertex will be somewhere in the middle, right? And we're going to add to that on the next page. Don't worry. All right, so before we go to the next page, there's a few different scenarios we want to talk about, right? There's 3 of them. We get 3 scenarios for x-intercepts. All right, so our first scenario is the one that we are most often used to seeing. And that's like something like this. How many x-intercepts are there? 2. So that's your first scenario. 2 x-intercepts. But that's not the only situation. How's that possible to have anything other than 2 x-intercepts? What do you think? Is there any other possibilities?
The vertex is on that.
Yeah, you could have 1. What if the vertex is right on the axis? Right? That would be 1 x-intercept. Right? And we'll find out what that looks like in a form. Okay? And then, I said 3 scenarios.
It doesn't go through it?
None of them.
You could have none. You could have a parabola up here. Or you could have a parabola down here. Right? No x-intercepts. And that will cause, we wouldn't be able to do that in intercept form because there would be no x-intercepts.
So, would it be like, we wouldn't be able to do this problem, or like, how would that work?
We just would have to use another form.
Okay.
Right? Okay. All right, so let's move on. So what I want you to do now is you're going to take another look at the warm-up. So it's the graph from the warm-up is on the next page, right? And then you're going to answer some questions with your information that you've learned so far, okay? So here's the equation, same equation we were dealing with. Here's the graph, right? Answer these questions. It shouldn't take too long. And then we'll go over the answers, okay? And then we'll just do one more example, and then we'll be done with the lesson, okay? All right, so the question was, what do I mean by the form? Save the form. We know there's 3 choices. What are they?
Intercept vertex.
Intercept form, standard form, intercept form, standard form, and vertex form. Which one is this one in? What have we learned? Intercept form. So that's the answer to the first question. Yeah, there's 2 parentheses. There's no actual squared except for it being implied. Like you don't actually see a squared in the equation. It's intercept form. Okay? All right, so we're in intercept form. Okay, what relationship can we tell the equation has to the graph? Remember, each form gives you things on the graph, right? Vertex gives you the vertex. Standard form gives you the y-intercept, and that's about it. This thing gives us stuff. What does it give us? A couple things, yeah.
The stretch and reflection.
The stretch and reflection, right? So this 2 tells me, well, starts here, it goes over 1 up 2, right? It goes up 2, right? So our A equals 2, and there's a stretch of 2. And there's no reflection, right? What else can we see as a relationship between this graph, the x-intercepts, right? Which is why it's called intercept form, right? We have intercepts at -4 and -2, right? -4, 0, and -2, 0. And in our equation, we have a p of -4 and a q of -2, right? Because we flip the sign to get our p and our q, okay? So it says use the graph to write the equation in vertex form. We actually already did that on the front. So we don't need to do that again. Okay. On the front, you would just take the vertex, plug it into vertex form with your stretch. Okay? All right, so the last thing we're going to talk about is graphing from intercept form. I'll give you some steps, I'll give you an example, and then we'll be done. Okay? So, graphing from intercept form. Let's talk steps first. Well, actually, we'll go steps and example at the same time. Okay, our first step is to pull out our pieces. Right? And we know our form is y equals a times x minus p, x minus q, right? So we need to pull out those three pieces, a, p, and q. So let's say I have the example, y equals negative x minus 1 and x plus 3. And I want to know, well, what is my a, what's my p, and what's my q? Actually, I'm going to write those. Give myself some more room here. So what's my a, what's my p, and what's my q? It's not 1, it's negative 1, right? There's an imaginary little 1 here. So a is negative 1. My p, positive 1. And my q, negative 3. Right? We flip the sign of the p and the q. And now we have our pieces. So 2 is plot your x-intercepts on the graph. We know our x-intercepts now are 1, 0, and negative 3, 0. Right? So I go to those 2 points and I add a point. Right? We're on our way. We have points on the graph. It's always good. All right, step 3 is we find our axis of symmetry. Now, there's 2 ways to do that. Anybody remember where the axis of symmetry was in our, like if you look up above, it's in the middle, right in the middle, right? It's in the middle. So you can find that by just looking at your graph and saying, okay, what's in the middle of negative 3 and 1? Negative 1, right? Right down the middle, right? So for us, it's x equals negative 1, right? Right down the middle. Now, this is for graphing, which you'll always be able to tell where the middle is, but you're going to be asked for the axis of symmetry when you don't have a graph and you just have an equation, so you need a formula too. So the other way you can find it is with a formula. X equals P plus Q divided by 2. Why does that make sense? Well, if you add 2 things together and you divide by 2, you're finding their average, and the average is the middle, and that's why that formula works, right? So you're just finding that middle spot algebraically. So that would be, for us, negative 3 plus 1 divided by 2. That's negative 2 divided by 2. That's negative 1, right? So it still gives us our value.
Wait, Mr.
Mm-hmm.
So, how do you, the lines that are the green dots, did you place those? Because wouldn't it be, if you flip the sign, positive 1 and positive 3, so where they go?
Positive 1 and negative 3.
You have to flip both signs. So this negative 1 becomes 1. This positive 3 becomes negative 3.
Okay.
Good question, though. Okay, almost last thing is we find the vertex. And once again, we got to plug in our x to find our y. Okay, so for our equation, that's y equals negative 1 minus 1 and negative 1 plus 3, which is negative 2 times 2, which is 4. So our vertex is negative 1, 4, which is up here, right? And then the last step, what's up?
Oh, because you plugged it in.
I just plugged it in. Yep. And then the last step is to just add more points using your stretch and your reflection. Well, you can already see this is flipped down. That kind of is confirmed because we know negative out front. We would have expected that, right? And we know it's just 1, so there's no stretch. So over 1, down 1, back 1, down 1, and now we got 5 points, and we have our graph. Okay?
How do we find the points?
The points I just added?
Yeah.
Remember your parent function, right? If there's no stretch, it either goes over 1, up 1, or over 1, down 1, right? Over 2, down 4, back 2, down 4. Those things still work, right? All right, and then you have your graph, right? So you want to plot your x-intercepts. Well, first you got to pull them out, plot them, find the middle, one way or another, plug that in, you got your vertex, and then you have your graph, okay? Questions? All right, so who's ready for homework?